What's poppin', dogs? Mr. Allen here with some average rate of change, or AROC, as we like to say on the mathematical streets, of a couple different quadratic functions here, and one of them has a graph as well. Very exciting. So first one here, given the quadratic function, f of x equals x squared minus 5x plus 4, what is the average rate of change, or AROC, over the intervals 0, 3 and 2, 5? So really like two examples here. So let's find this first one here. We'll do it in pink. So average rate of change is another way of saying slope. All right. So slope, I know my slope formula is change in y, or y2 minus y1, over my change in x, x2 minus x1. And you could go through it that way, but I find it very helpful to actually write down our average rate of change formula in function notation. So what we're going to have here for our AROC, for this pink one, AROC, over that interval, is going to be f of 3 minus f of 0 over 3 minus 0. So this is my change in my y values, right? When I plug 3 in, that's my y value, that's my output. When I plug 0 in, that's my output, that's a y value, over 3 minus 0. The nice thing about function notation with average rate of change is that I don't mix up the order of my x's and y's, because as you can see here, it's y2 and x2. They need to be in the first position. If y2 is the first one here, x2 is going to be the first one here. If you flip-flop them, then you get an opposite sign, positive when it should be negative, negative when it should be positive. So the function notation really helps you stay organized. So then I got to do f of 3. Well, if I plug 3 in, let's do a little side work here. So I'd have 3 squared minus 5 times 3 plus 4. So that's 9 minus 15 plus 4. That's going to be negative 6 plus 4. That gives me negative 2. So we're going to have negative 2 minus f of 0. That one's pretty easy. That's 0. It's just 4. So minus 4 over 3. Well, this works out well. Negative 6 over 3 equals, and we get negative 2. So my average rate of change is negative 2. Nice. First one, donezo. All right, next one. Hopefully we won't run out of room here. I took up a bit of space there on that one. So average rate of change for this one here now in blue is going to be, let's write it out here with our function notation. We're going to have f of, I can either do 2 or 5. It's actually up to you. I'll do f of 5 minus f of 2. Everybody always seems to do like the second one first. I don't know why that is, but it is. All right, minus 2 there. So as we can see, we've got them in line, right? The 5s and the 2s. So what is f of 5? Well, because I'm running out of space here, let's do it in the calculator, okay? I'd have 5 squared minus 5 times 5. Actually, this works out pretty easy now that I think about it. 5 squared is 25. 5 times 5 is 25. That's 0 right there, so that was just going to be 4. All right? This is all over 3 here. F of 2. We've got 2 squared is 4. 5 times 2 is 10, so 4 minus 10 is negative 6, plus 4 is negative 2. Let's just double check it. I don't want to screw it up, right? 2 squared, 2 squared minus 5 times 2 plus 4, it is negative 2. Okay, so minus negative 2. And then we get ourselves, that's positive then. I have 6. So this equals 6 over 3, which equals 2. Interesting. I did not plan that to be the positives and negatives of them. They are both 3 apart, but depending on how this is, you know, how it shifts around the parabola, as you get to the farther ends away from your vertex, your average rate of change is going to be greater over the same interval, right? We can actually see that over here on this graph. You know, from here to here, a change in 1 this direction is going to be less steep than a change in 1 from here to here. Right? That's going to be very steep. All right, so coincidence here on the 2 and negative 2, but that's cool. All right. Another question they can ask you on these would be like, for which interval is the average rate of change greater? Right? That'd be from 2 to 5 here, because it is positive. So even if this was just 1, it would still be greater. Okay. So they have different types of questions here. Be on the lookout for those types. Okay. Next one. Given the graph of f of x equals x squared minus 3, it's already been graphed for us, and I give you the equation. Sometimes they'll give you the equation, sometimes they won't. What is the average rate of change over those two intervals? So let's do this one here in green. And now I'm going to write it out. So we'll do f of negative 1 minus f of negative 3 over negative 1 minus negative 3. Well, f of negative 1, I can just look at my graph here. Negative 1 is negative 2. And negative 3, 1, 2, 3 is up here at, is it 6? 1, 2, 3, 4, 5, 6. Okay. So minus 6, right? So f of negative 1 was negative 2. F of negative 3 is positive 6. And then we're negative 1 plus 3. So let's see. We got negative 8 over 2. So it's negative 4. All right. Average rate of change, negative 4. And it does look like it's actually a pretty, steep negative slope there. So that makes sense. You can even count it out. We're going down 8 over 2. That's exactly what we have right here, too. All right. So a lot of ways you can slice this one up and analyze it. But function notation, I really like this when you're talking average rate of change and slope. It's just a nice, neat notation that keeps things in line so you don't flip-flop, get the wrong sign. Okay? Last one here, negative 2 to 2. So we're going to have f of 2 minus f of negative 2 over 2 minus negative 2. So that becomes positive right there. And f of 2, what is that? F of 2 is 1 minus, and then we have 1 over 4. Wait, what's 1 minus 1? That's 0. Is this some kind of an error? Is this something wrong here? No, it's not. It is 0. And then I'll circle it, and it looks weird. It's a horizontal. Look at that. Yeah, if we're going from negative 2 to 2, that's a horizontal line. So my average rate of change is going to be 0 for a horizontal line, right? So it does actually make sense. Don't be freaked out if you see like an average rate of change of 0. It can happen, okay? I know we get all the other numbers all the time, and every once in a while 0 pops up and you're like, is that okay? Is that all right? Is this something illegal? Am I going to go to math jail? Not in this case. It's still possible in other times, but different situations, okay? So there we go, average rate of change. So that's dope, super fun. And average rate of change continues through everything, calculus and beyond, okay? So it's here to stay. And hopefully you guys are here to stay too on Mr. Allen Math YouTube channel. All right. Have a wonderful day, guys, and keep on mathing.